Hello and welcome to part two of replacing my Google Home with Claude Code. Today we are going to be talking and walking through the wake word listener. To create that Google Home experience, I want to be able to just, shout out to Claude to get started on something. And I finally got that working nicely and consistently, and of course running locally, which is pretty important for this project. And let's get into it. We'll just talk through how it works and then show a quick demo. So for the Claude Code architecture here, the Claude Home, the ambient Claude Code, we have a wake word listener. We will use that to trigger a process to capture the audio. To make it easier, we will then have Grok use one of the whisper models to do a quick transcription, get that speech into text, and then have that push into the Claude Code SDK. To talk through a couple of the architecture decisions here, we want to be able to have a process running in the background locally on my computer that I can say, "Hey, Claude," to, and then it'll initiate the process. So we want it to be an ambient process, and that means it needs to be running locally, free, and just always on. For that, I am using the whisper.cpp library here from GGML, and they have a nice example of how to stream. Sorry, where to go? Real-time audio inputs. So we're streaming text in just constantly from the microphone, listening for that wake word, and then a little bit of logic to know when the text is done running. This is definitely not the most efficient implementation. There are other libraries like Open Wake Word, which would be a much more power efficient way to do this. But I want to be able to say, "Hey, Claude," and to do that with Open Wake Word, I would have to train a new model, and that's a future improvement. It's just not it was a little more complex than I was initially looking for, and we'll circle back on that. So we are using a smaller whisper model to listen for that wake word, and then we're capturing the audio because we want the full high quality transcription from a remote model. So we are transcribing everything that's said with a local model and just throwing everything away that's not the wake word, and then capturing the full audio. Once that wake word has been detected, we use Grok to transcribe that super quick, and then we pass it to Claude Code. A quick look at the very minimal UI here. Claude Code is set up, or Claude Home here is set up to be able to add G Suite integrations and Spotify, and also to-dos. We can look at that a little bit later as well. That'll probably be another video. Let's do a quick demo and then we'll talk through the code. So there are two processes here. I have a server running locally, just a little bun server. That's where all the heavy lifting happens. And then we have another process for listening to a wake word, and now it should be able to work. "Hey, Claude, could you please tell me about my to-dos?" All right, so we see that we got the wake word detected here and it ended. And now we see Claude Code spinning up. I did not hear the audio, so we'll
I'll check your to-dos for
through.
you right now and let you know what you have on your list.
So here we're using a text-to-speech tool in Claude Code, and it's now listing out my to-dos, and it'll probably do a little bit of thinking here and then continue to explain my to-dos to me using that text-to-speech tool. So here we go. Now we can see the results back from that. We'll listen to it for a couple of seconds, and then I'll kill the process there. This is not streaming,
Here's
so
what you
we
have on your
can make
to-do
that
list.
faster.
You have 8 to-dos total, with 1 currently in progress. Let me break them down for you.
All right, I killed that process just so we didn't have to listen to the whole thing, but that's the core flow of we were able to use the wake word trigger from this process. It essentially did the Grok transcription and then passed it off to Claude. Claude's now using a bunch of MCP tools to look at my to-dos, and then talk that to-do list back to me. For our last part of the deep dive here, we'll walk through the listen for wake word process, and call it a wrap there. So the piecing the heavy lifting here is just a child process kicked off in this bun script that loads the model and then does the actual listening and transcribing. That process has the standard output here. And as text is thrown off from that standard process, we process it and look for the wake words. We first clean the text and remove a bunch of fluff that we don't need. And then we listen for, or we check for blank audio. This is an indication that there's no more text coming through or no more audio coming through. And we should end the process there if applicable. And then our wake words here are, I want it to be "Hey Claude," but the model does not quite pick that up consistently. So we also get "Hey God," "Hey Quad," "A God," "A Claude," "A Glod," "Take Quad." So I sat here for a couple minutes just talking and saying "Hey Claude" over and over again, and these were 80% of the transcriptions for that. If I enunciated better or had a better model, I'm sure we could trim that a little bit. What happens is if we get the wake word, we handle the wake word, and we process that by starting a FM PEG or FM PEG. I don't know the way to pronounce that is. We start then a separate process that records the audio file, records the audio from the mic. We save that to this file, and then we post that to localhost. This could be integrated into localhost. This is just a little bit easier to keep it as a separate process. And there you have it. Just like that, we now have a wake word process running on our computer that we can use to trigger events in our main application, which then continues to run the entire Claude Code SDK. All right. Thanks so much for watching. Have a good day. Part 3 coming soon. All right. Bye.